Now, let's talk a little bit about measurement method. Adjacent measurement period. This method is used for energy conservation measures that can be easily turned on and off, allowing direct comparison between energy use with and without the ECM. Right. So with ECM off, the then we measure the energy consumption during the baseline period, and with ECM on, right, measure energy consumption during the reporting period. So off, measure the before the project, we measure the baseline, and after the project implementation, we see ECM on, we can report period. Uh, the reporting period can be measured on and off, and savings are calculated as difference. So the example here is lighting control system. Maybe we install a lighting control system that automatically dim the light during daylight hours, and the baseline period would be the control system is turned off, energy use is measured for a few days, for example. Then for the reporting period, the control system is turned on and measure the energy use under, again, under the same conditions. Remember that, under the same conditions. Otherwise, adjustment would be needed. Then the saving calculation would be the difference between the two, right? The reduction of the energy use from the reporting period. The advantage is very simple and direct. There's no need for complex adjustments. If conditions, again, if conditions remain the same, very quick verification, right? So it's very useful. This method is very useful for project with immediate impact, like lighting system. The limitations is the external factors. If there's a change, if the savings are affected by the weather, the occupancy, right, so on and so forth, then this is the limitation for this method. And it's not suitable for all ECMs. This method works best for, again, ECM that can be toggles turn on and off without disrupting the, say, operations. So adjacent period, measurement period. Since this method assumes all other factors remain unchanged, it's crucial to ensure the on and off measurement time intervals are adjacent, so right after the other, one right after the other, right? And this minimizes the risk of external influence. Okay. The one key consideration is that the ECM must stay on after this method. Okay, don't sometimes if we do this measurement and we forgot to keep the ECM turned on. So after the ECM has been tested and proven effective, it's essential to verify that it remains on after the measurement period. Otherwise, there's no energy savings, right? Okay. Let's now discuss the different phases in MMV. That's the pre-implementation and post-implementation phase. In the pre-implementation phase, we create a plant, MMV plant, right? An MMV plant. Develop a detailed measurement and verification plan procedure that outlines the methodology, the data collection procedures, the measurement parameters, reporting requirements, right? Documentation. This plan forms the blueprint for how energy savings will be measured and verified. Collect baseline data. We gather historical energy consumption data, utility bills, meter, sub-meter data under normal operation conditions. That's the baseline represent business as usual scenario and serve as the reference point for calculating the savings, right? Sets the reference. Then there is the post-implementation phase, which verifies the, first we have to verify the energy conservation measure installations, ensure the energy conservation measured has been properly installed and it's operating as designed, as expected. So this can involve, say, on-site inspection, performance test, right? Also, it can involve installing meters if required. If the MMV plan calls for detailed sub-metering to isolate individual ECM impact, then install and calibrate these meters to accurately capture energy consumption specific to each ECM. Okay. Collect energy consumption data during the reporting period when the ECM is operational. Record the energy consumption data using the same methodology as the baseline to maintain consistency. Okay, and determined savings, that's the last step. Compare the post-implementation energy consumption data with the baseline, right? Adjusting for external factors, of course, if necessary. The difference calculated as defined in the MMV plan. That represents the energy saving achieved by the ECM. Right? So it's a structured approach that ensures that savings are accurately measured and verified, and that gives us the confidence in this efficiency project. Now, back to cost and uncertainty again. Right? Cost in MMV program depends on several factors. Meter quality. If we require high quality precision metering and sensors, it costs more, but it's also more accurate, more reliable data. Number of parameters, depending on how many. Measuring more parameters, voltage, current, temperature, flow rate, etc., right? Require additional instruments, data channels, and so it increases the cost. Frequency of measurement. How often? Like, what's the sampling rate? Every second, every minute, hour, every day, right? So the frequency of measurements, you can imagine if it's every second, the data would be exported, right? So higher sampling rate and continuous monitoring system will give us more data, but it requires more advanced data loggers, storage, which will jack up the cost. Okay, and also the length of baseline. How long? How long is the baseline? How long is the reporting period? The longer, both before and after, right? The ECM. The longer the period, the more the cost, the more the effort required. And sample size, right? Sometimes, if not all the equipment is meters, representative sample must be used, like some kind of average or estimate must be used, which may require additional analysis and calibrations to make sure to ensure that accuracy. Okay, so there's a balance between cost and uncertainty. Okay, always a trade-off between the two. If we invest more, then give us the more better quality data, capture more parameter at higher frequency, stuff like that. But we also need to optimize the resource, right? The key is to design a MMV plan that minimize the uncertainty to an acceptable level without overspending, right? For smaller, simpler ECM, we can use a simpler, less detailed approach to minimize the cost. But for more complex projects, where it's a capital-intensive project, you want to make sure you have, you don't want that the uncertainty destroy the project. Put it that way. So balance between uncertainty and cost. Okay. So in general, it should be less than 10% of the savings. Ideally, less, 3 to 5% common for energy retrofit projects. And if no measurement, then 0% cost. But this savings is deemed savings, right? Deemed savings. Okay? For many energy retrofit project, MMV expense just fall within this 3 to 5% range. And this level strikes a good balance between enough data, enough accuracy, and the keeping the cost low, right? And if no measurement at all, when savings are deemed rather than measured, then there's no direct measurement effort, no cost. However, right, while this approach saves money, on verification, it often comes with increased uncertainty. Just keep that in mind. The MMB principles. So let's spend a bit of time talk about the principles. Accurate, right? Accuracy. The MMV protocols, this methodology should capture energy savings as precisely as possible, using the best available measurement tools while staying within the budget, right? Budget. Complete, all effects are considered. So it's important that all effects that influence energy use are considered, from baseline condition to external factors, ensuring the full impact of the ECM is captured. Conservative, for safety reasons. Well, assumption estimates should be made conservatively to protect against overestimations. This means that reported savings are more likely to be at or below the actual savings, providing a safety margin for the stakeholders. Okay, people do care, and so we want to be safe, right? Consistent for reporting. Now, when we report the savings, there has to be consistency. Standardized method procedures must be applied throughout the project, ensure the comparison and reporting are reliable and repeatable over time across different projects. Relevant, right? Relevant. The focus should be on measuring key parameters that directly influence energy consumption and savings, rather than collecting extra data that does not affect the outcome. Okay, so relevancy is important. Finally, transparent. Well, for disclosures of the measurement methods, we have to let people know how we do the measurement. It has to be transparent, no guesswork here. And and uncertainty is essential, right? This openness builds up trust with stakeholders and allows independent verification of the savings that's claimed. So these are the MMV principles. So we have touched on a list of topics here that's kind of summarize what's in MMV planning, right? First, the ECM intent. We clearly state the purpose and expected benefit, or why we do something because it's beneficial, right? So expected benefit of the energy consumption measures what the project aim to achieve. That's the intent. IP and VP, options and measurement boundaries. We have to decide which option to use, which one is the best for the project, and set up a boundary. Is it option A, B, or C, and the D, the simulations, right? Depending on the options, the boundary are different. Defines the it specifies which part of the facility or system will be measured. Okay. Baseline. Baseline it establishes the baseline period and conditions. This includes documenting the pre-project energy consumptions, relevant operations conditions, and external factors like weather and occupancy. Okay, reporting period. Identify the time frame during which post-implementation energy data will be collected. This period should be just long enough to capture the performance. We don't want it to be too short, but we don't want it to be too long either. Yeah. The basis for adjustment, that's a very important one. It describes how adjustment will be made for variations in weather, in production level, things like that. Okay. Analysis procedures for saving calculations. So it details the methodology, statistical method, simulation, or just simple subtractions used to calculate energy savings based on the difference between the baseline and the reporting period. The utility price, well, utility price, it varies at different jurisdictions, right? So specify the rate or price, the cost of the energy use to monetize energy savings. Ensure the cost savings can be accurately valued. That's also an important one. Meter specifications include details about which meters or sub-meters sensors used to collect data, such as their accuracy, resolutions, right, and their calibration status. And what are the expected accuracies, right? Include details about the meters or sensor used, and outline the expected measurement accuracy, uncertainty associated with the savings, the calculations, ensure the transparency and reliability. Budget, or provides an estimate of the costs for the MMV costs and ensure the plan remains cost effective. Again, typically within 10%, generally, hopefully, ideally 3 to 5. Right? And the report format describe how the final result, the method, the assumptions, they all have to be documented and reported to stakeholders. for transparency and verification. Okay. So this is again a structured approach that ensures the MMV process can be trustworthy, transparent, consistent. Last topic, emission trading. It's an instrument designed to achieve emission reductions at the lowest cost possible. Okay, here's a brief overview. It enables companies to meet legal set emissions, right? The caps in the most cost-effective way. Instead of each company, individual companies, reducing their emission internally by themselves, they can trade this emission credit. So how it works, let's say we have emitter A reduce its emission at a low cost per ton, right? And overachieved and exceed its regulatory target and therefore generate credit. Then there's the emitter B. It faces very high cost to reduce its emissions, so it opt to buy credit from others, like from emitter A, right, to comply with the regulations. Right, so you can trade emissions credit. Now, the market, the trading it's common in market for these gases, right? These gases, not just CO2. This market enable the trading of credit and help allocate reduction efforts where they are most economically efficient. Right? Debatable, controversy sometimes, but that's one way to do it. Environmental performance. Since the emissions saved by the sellers are essential and re-emitted by the buyer, the sellers cannot, once you sell the credit, basically once you sell the credit, the seller cannot claim an overall environmental improvement beyond the compliance. Okay, so the system ensures that overall emissions remain within the cap, but individual credit do not equate to a net reduction if it's emitted, like you sell the credit and emission somewhere else. Okay, so the role of MMV measurement and verification, it's adhere to robust MMV practice, right? Like IPMVP, enhance the credibility, the value, okay, of this emission credit by ensuring that reported savings are accurate and verifiable. So this mechanism encourages companies to pursue the lowest cost. Well, makes sense, right? You don't want to pay a high cost. So the lowest cost reduction, and while maintaining an overall emission caps. Okay, even it means trading credits among different emitters. So that's the end of module 6. Now, since we are not going to meet in person this week, if there's any question or suggestions, feel free to let me know, message me, email me, right? And let's keep the communication open. So hopefully these videos will give us help us give us some understanding of the MMV procedures, what it is, why it's important, and I hope to see you after the reading week. and there will be a field trip, right? It's just confirmed. I just confirmed just an hour ago that we will be going on March 19th. But let me send you the message as a confirmation. Okay. Bye for now.